Alright guys, this is a review of the rock cycle and our rocks unit in general. We're going to start in the bottom right hand corner over here with melting. Once you melt any sort of rock, it's going to turn into molten rock. Now molten rock is really any sort of melted rock, but it can exist in two places. You can have molten rock below the Earth's surface, that's magma, or you can have molten rock that's at or above the Earth's surface, and we're going to call that lava. The only difference between magma and lava is where it is, it's geography. Once you have that molten rock, you're going to begin to cool it down, you're going to solidify it. That process is called crystallization. We simulated the process of crystallization. We took a couple of metal dishes, put some salt water in each one, and one of them we put underneath heat lamps to evaporate all night, and the other one we put in the refrigerator to cool down. And, well, what we got two different types of textures. The one that had the big crystals, that's an intrusive texture. And what that means is that it's coarse-grained. It cooled off over a long period of time, so the crystals got really big. The one that we put in the fridge is simulating an extrusive igneous rock. Didn't have a lot of time to cool, so it got very small crystals or fine grain, and we get our two different environments, the intrusive and the extrusive. The big difference is going to be the cooling rate to produce the different crystals and also where they are. Tying the vocab together, extrusive igneous rocks formed from lava, intrusive igneous rocks formed from magma. Well, now that we have our crystallization process complete, we have our igneous rocks. And these are rocks that form from molten rock that cools and solidifies through the process of crystallization. There's two different types of chemistry of igneous rocks that we talked about. We talked about mafic igneous rocks and felsic igneous rocks. The big difference is this, is that mafic are going to be made of metals like magnesium and iron, and felsic will be made of silicon and oxygen. The mafic rocks will be darker in color, the felsic rocks will be lighter in color. Now the mafic will also be more dense, and the felsic will be less dense, only because of what they're made out of. Now that we know a little bit about igneous rocks, you should be able to fill in these two highlighted guys here in the middle left. Speaking of, I'm going to cruise over to the far left over here with this word sediments, which should be a big clue that we're talking about sedimentary rocks. Well, what happens? What are sediments made out of? Sediments are made out of weathered and eroded bits of earth material. What's the big difference between weathering and erosion? Both weathering and erosion are the physical and or the chemical breakup of any earth material. The only big difference is that weathering doesn't have any movement and erosion does. And what I mean by that is this. Maybe you have an elephant walking across the land and that elephant is busting up rocks. That would be weathering. Erosion, you have some rocks that are blowing across a desert, and as they're going across the desert, they're skipping around and breaking up. That would be erosion. But in either case, it's the chemical or physical breakup of earth material to produce sediments. And sediments can be made of any sort of earth material. What I mean by earth material are little bits of pre-existing rocks, maybe little bits of minerals, broken up shells, some organics such as plant matter, tree roots, and stuff like that. Now that you have your sediments, you got to turn it into a sedimentary rock. There's a process for forming sediments into a sedimentary rock, and that's called lithification. There's two types of lithification processes. You modeled this in class as well. The first one, you took a little paper cup, you put some sand, threw some salt water in there, mixed it up, evaporated the salt water overnight underneath the heat lamps. That's the process of cementation. What happened? The water evaporated, the salt was left behind, and the salt held those sand grains together. And you got that little hockey puck of sand. Later on that day, I gave you a bunch of food products, Rice Krispies, graham crackers, chocolate chips. You smashed them all up. You weathered them in the bowl with the spoon. And then you took a piece of wax paper and you squeezed it all together and made kind of a granola bar out of it. Well, those are the two different types of lithification processes. You have compaction, which is squeezing stuff together from pressure, and the other one, cementation, which is gluing sediments together to form a sedimentary rock. Once the lithification process is complete, we now have our sedimentary rocks, and it's also important to note that there are three different subclasses of sedimentary rocks. First one we're going to talk about is clastic. A clastic sedimentary rock are made of weathered up bits of rocks and minerals that already exist. The next one's organic. An organic sedimentary rock are made up of little bits of shells, maybe some organic materials such as plant matter. And the last one comes from the evaporation of water, producing a chemical sedimentary rock. Rock salt's a really good example of this. Water evaporates, leaves the salt behind. And now that we know this, you should be able to fill in the other track that leads up to the sedimentary rocks here on the right-hand side, which will only leave us with the metamorphic rocks down in the lower right. And that process is going to begin with HTP, with high temperatures and pressures. Once you have high temperatures and pressures, you're going to begin the process of metamorphism. Metamorphism, applying high temperatures and pressures to any pre-existing rock to change it into a new rock. But the important thing here is that it happens before melting. Once it starts to melt, it's going to turn into an igneous rock. There are two different environments of metamorphism, or two different types of metamorphism. There's regional and there's contact. Contact metamorphism happens over a very small area, and it's going to be higher temperatures than pressures. So those will be like surrounding a volcano, not in the volcano, but they're surrounding the heat of a magma chamber where the rocks can change a little bit chemically due to that heat. Excuse me. And the next one's going to be regional metamorphism. Regional metamorphism is going to happen over a larger area. This would be like near plate boundaries where big mountain belts are forming or huge pieces of earth are slamming into one another. So that's going to be larger pressures than temperatures. Now, what's going to be a big difference between them? Well, you did an activity to highlight this too. When we took the Milky Way bar and we crushed it underneath the weight of the book, we saw those layers compress and squeeze down. That would be regional metamorphism. That's a change in a rock due to pressure. So we saw how the layers within the Milky Way bar got spread out and they made these bands, these long bands. That's called foliation. And in the second part of the activity, you took a couple gummy worms, put them on the foil, and put them under the heat lamp for a little bit. When you put them under the heat lamp, they warmed up, but they didn't melt. And then we folded them over, we folded them together on that piece of foil, and you got something completely new before those gummy worms melted. That's really important. Otherwise, again, it's going to turn into an igneous rock. And that's how you get contact metamorphism. All right, so in this activity, now we covered the entire rock cycle. I forgot about the two triangles at the bottom. Those are leading to metamorphic rocks, so given the information we just talked about, you should be able to fill those in. And that's a review of the rock cycle and our rocks unit in general. If you have any questions, please ask me in class.